This lesson is on three-dimensional Pythagoras and trigonometry. In order to access this lesson, it's very important that you go back into the Key Stage 4 website and you look on the lessons on Pythagoras Theorem and on trigonometry. Okay, so what we've got here is a three-dimensional shape, okay, a cuboid, and we've got the dimensions of that cuboid are 5 centimetres by 2 centimetres with a height of 3 centimetres. And what have we been asked to calculate? We've been asked to calculate the length of BF and angle DBF. Whenever doing a three-dimensional trigonometry or Pythagoras question, the most important thing is you must identify the right angle triangles that you want to work with. So let's start by looking at where length BF is. It's from this corner of the cuboid down to this bottom part of the cuboid, so it's this line inside here. So what's the first thing I've got to do is I've got to identify a right angle triangle that holds the length BF. And quite clearly, if I just join D up to B here, you can see that we have this right angle triangle here, and inside there we have got the right angle. So let's now look at this triangle DBF. Let's pull it out here and just have a look at it. Okay, it's got a right angle we know at angle D. Okay, the length that we're interested in calculating is this length BF. And what we're going to do now is going to put some dimensions. Let's see what we've got on this triangle already. Well, actually we've got the height, okay, because the height of this cuboid was 3 centimetres, which means FD is also 3 centimetres. Now, in order to calculate BF, I'm thinking to myself, have we got DB? Because I know that if to use Pythagoras, I need 2 sides with 1 side missing. And remember, I'm going to put X here now, that's the length that I'm trying to calculate. So I'm now looking at DB and saying, no, I've not got that length. But what I've got is I have got a right angled triangle which contains DB. If you just look here, okay, there and there, I've got a right angled triangle. So what am I doing is I'm going to take that triangle out. I'm going to work at calculating DB. Then once I've calculated DB, I can then go back to this triangle and be able to calculate BF. So if you look at this triangle here, okay, I've got a right angle at A, okay, so I've got a D, I've got an A, and I've got a B. There's my triangle inside here, like this. And what lengths have I got on that triangle? Well, I know AB is 5 centimetres. I know DA is that length going across there, which is 2 centimetres. And I can now, using Pythagoras, be able to calculate DB. Remember, I've got to work out first which of the sides it is. Well, it's definitely the hypotenuse side. It's the longest side. So remember when we did Pythagoras, what would Pythagoras say about this triangle? If I label that as X, it would be X squared, the hypotenuse side squared, is equal to that side squared plus that side squared. So X squared is equal to 4 plus 25, which is 29. So X equals the square root of 29. A tip here, don't go working out the square root of 29. Just keep it as the square root of 29. The reason we're going to keep it as the square root of 29 is because we're going to use that again in this next triangle. And remember, when you square a square root, it gives you the original number. So a little tip here, keep the answer as a square root of 29 rather than going to your calculator and square rooting 29 and then rounding it, say, to 1 decimal place. Because we're using the square root of 29 again, it will keep all the accuracy. Okay, so what have I now done? I've calculated that length BD to be the square root of 29. So if you just go back to my three-dimensional diagram, I now know that that is the square root of 29. I now know this length there is 3. There's my right angled triangle that I'm interested in working with down here. Okay, so I'm now dropping in DB is the square root of 29. And now, using Pythagoras, I'll be able to calculate the original length that the question asked for, which is the length of BF. So, what would Pythagoras now say about this triangle? That's the square of the hypotenuse. So that squared plus that squared fits that large square. So X squared equals 3 squared plus the square root of 29 all squared. You can see now why I kept it as the square root of 29. Because if you do the square root of 29 times the square root of 29, you end up with 29. So you've not lost any accuracy. If we took the square root of 29 here and you rounded it to 1 decimal place, then when you then re-square it, you've actually lost quite a bit of accuracy because the answer actually is 29. So we've now got x squared is equal to 9 plus 29. So I add the 9 to the 29 and I get a grand total of 38. So x is equal to the square root of 38. Type that this time into your calculator and you get a final answer to 1 decimal place of 6.2 centimetres. Let's look at that next question. It says calculate an angle. So we've done three-dimensional Pythagoras. We're now looking at a little bit of three-dimensional trigonometry. Okay, so I'm now going to this triangle here because the angle I'm interested in is this angle, angle B, inside there. So remember the technique, okay, with trigonometry, we label from the angle in order to find the appropriate ratio. So I'm labeling from this angle here. Remember, this is the hypotenuse side. This is the side that's opposite the angle I'm trying to find. And this is the side that's adjacent, okay, to the angle B that I'm interested in. Now I've actually got all three sides. All right, so really I could use any of the ratios. Any of the ratios that I want to use, I'll be able to calculate that missing angle. Because I've calculated the 6.2 and I've rounded it to 1 decimal place, I'm actually just going to use these two sides because they haven't been rounded. So just to keep as much accuracy as possible, the ratio I'm going to use is one that involves the opposite and one that involves the adjacent side. So which ratio involves the opposite and the adjacent side? Remember to go back into the lesson that we did on trigonometry if you're not too sure, but that is the tangent ratio. So the tangent ratio is tan of my missing angle. My angle, remember, is angle B, is equal to opposite over adjacent. The opposite side is 3. The adjacent side is the square root of 29. And don't forget how we get rid of tan. We press tan inverse on our calculator and we end up with x equals tan inverse of 3 over the square root of 29. And to 1 decimal place, that gives me an angle of 29.1 degrees. So, it doesn't have to be cuboids. You can have any three-dimensional shape. Okay, square-based pyramids are very popular. Okay, triangular prisms. The key thing, though, with three-dimensional trigonometry and Pythagoras is just keep identifying where the right angle triangles take place. And then work. Often you have to do 2 calculations before you get to the triangle that you're interested in to be able to answer the questions. Thanks very much.